This session we are going to discuss about Argo architecture, Argo workflow architecture. So basically when you deploy the Argo workflow, you majorly have two components here. So one is Argo server and second is workflow controller. What is Argo server and what is workflow controller? So workflow controller is, you can say, is monitoring the workflow, queuing up the workflow, uh, all these things. Workflow controllers does it. It takes care of reconciliation process. It has bunch of workers who are responsible for handling the task. These tasks are to-do list, basically the queue, put in the queue whenever something new has added or updated. Then comes the main component of Argo workflow, that is Argo server, which handles all the workflow, coordinate tasks, ensure everything is running. You can say it is a backbone of Argo workflow. Let's go to the next slide. This is the graphical diagram how Argo workflow works. So you can see user can interact with Argo workflow with two ways. One is command line and second is web interface. Then they will be connecting through the network. It can be network load balancer. It can be a node port, ingress controller. Anything can be there. Then it connects to the Argo server service. This is the service. Since you can see this all things are running on top of Kubernetes. So this is the service of Kubernetes for Argo server. And here it connects to the Argo server. Argo server is running 3 replicas and controller is running 1 replica. And here you can see these all things like Argo server and workflow controller both are running in the same namespace. Okay, that namespace is Argo system namespace. Then the authentication mechanism is also there. Okay, webhook API client, they will be interacting through network. Promises controller, it will be talking to the workflow controller. In this diagram, again, same thing. We have namespace, which is Argo namespace. Argo namespace has two major components which it is running in form of pod. One is workflow controller, second is Argo server. Argo server is connected to the Argo server service. As well, to communicate Argo, we have Argo CLI and Argo UI options are available. Workflow controller and Argo server both are running in Argo namespace only. This is a workflow controller diagram. You can see API is there, pod informer is there, workflow CRD informer is there. Workflow CRD informer will inform workflow queue, and then workflow queue has some couple of workflow workers which is doing take care of communicating the rest of the things. So all the green dots which you are seeing is like informing, CRD informer, the pod informer, workflow queues. All these things are the part of workflow controller. Now the workflow controller, as I mentioned, it takes care of reconciliation process. So reconciliation process, you can say that, okay, there is a factory manager who oversees everything, whether something is running, ensure that everything is working properly, basically monitoring task. So that is reconciliation process. Then the workflow go routines. These are the workers. Okay. Each is responsible for handling the special part of workflow. They work on the tasks that are assigned to them. Okay. So these are the workers. These are the part of these worker go routines are the part of Argo server who is executing the task. Then the workflow queue is there. This is the conveyor belt or workflow need to be processed. When they want to process it, they need to go to the conveyor belt. A worker pick up one of the workflow from here and start processing them. Adds an update. This is when new products are added to the conveyor belt or existing products are updated. Workflow has to be executed again. Informer. This is Communication system in the factory. They inform the workers about the new product update. They different there are different informers for different types of tasks and workflows. Okay, what need to be done? Let's go to the Argo workflow internal, like specifically the server side of it. How Argo server works is. So as I mentioned, these are the worker nodes are there who is executing the workflows. You can say there are three workflows steps are there. Workflow one has step for multiple steps are there. Okay. So one step when it is executing, it has one init container is there, one main container is there, and one wait container is there in single pod only. Okay. So what exactly happens is the internal of pod are shown. Each step and each deck task cause a pod to be generated. Each of these is comprised of three container as I shown. Main container that runs the image which as a user we are defining it. Okay. Where the Argo executability is volume mounted and serves as the main command which calls the configure command as the subprocess. So this is important with the Argo exec. Then second is the init container fetching the artifacts parameter and making them available to the main container. Third is the wait container, which is you can say that needed to clean up and including the saving of parameter and the artifacts. Now let's go in the detail of main container. What is the purpose of main container? Exactly as a user, you are defining certain parameters. You say that okay, this has to be executed. This image I want to use for my application. So that particular thing user wants to perform it, main task. It specifies the image by the user. It includes the Argo execute utility, which helps to manage the task. Argo execute utility runs the main command as the subprocess, manage input, output, artifacts, parameter, all these things. Second is the init container. Prepare the environment before the main container starts. It fetches the artifacts, parameters. It makes these artifacts and parameters to the main container. Then third the wait container, which goes and clean up the things. Its purpose task is needed to be tied up. It saves off any output parameter artifacts produced by the main container. Summary. Whenever a task is run, a pod is created consisting of three containers, init, main, and wait. Set up everything need to be done by init container. Main container runs the task and wait container clean up the task. Now let's go and see the UI interface. In the UI interface, running locally with the React, so they are using React app makes start UI equal to 3. There are three things: index.html, TypeScript files are there, React app is there, just API call, invoke the type of Argo server. What exactly means is running make start UI equal to 2. Things of this is pressing a button that starts your project with a UI so you can see and interact with it. Then the React application, there is a part of your project that handles what you see and interact in the web browser. It builds on using the React apps. Then web HTTP server, this is like a local mini server that runs on your computer, handles the web page, index.html. Index.html and TypeScript files are the building blocks of web application. Okay, they are dynamically changing the interface and all those things. Then backend API is Argo Server. This part of your project that handles the data and logic of server side. When the UI need to interact and send the data and backend, the port number is 2746. Hot reload. Imagine you are editing a document and everything need to be changed. Automatically it will update it. Now, after that architecture discuss, we will discuss the lab part. Thank you everyone. I'll just upload this document